start chapter 3. And chapter 3 deals with relationships between quantitative variables. So remember, those are things that are numerical things. They're not categorical anymore. Does that make sense? Things like height, weight, not sex. Sex, male, female, that's a categorical variable. So what we use to represent these relationships are things called scatter plots. Have you guys seen scatter plots? Yes, there's like, lots of dots and stuff. This is a two-dimensional graph. Two-dimensional graph of the measurements for two numerical variables. And this thing will displays the relationship. Why do I not have an eraser today? Okay. Scribble. Between two quantitative variables. And I promise after next week I'm going to get smarter and start bringing you like 3 packets at once instead of 1 at a time. So you'll have to always pick up stuff. Okay. And I assume that most of you at some point in your life have seen a scatter plot. It's a bunch of dots, right? Okay. Sometimes those dots show a relationship. And the way you describe the strength of the relationship is something called the correlation. Make sure you grab a note sheet before you sit down just so you're not like having to come back up. So the correlation, this is a statistic. It's like a numerical value that measures the strength and direction of a linear relationship between two variables. And in this class, we're going to just go with the simplest types of relationships, like things that are linear, whereas like when you plot your points, they kind of seem to go in a straight line pattern. If you plotted the points of the temperatures in Fairbanks, Alaska, would they go in a straight line? What would they do? They'd oscillate, right? So they'd be like what would be like a sine or cosine function of some sorts. But stuff that's straight line relationship, I don't know, shoe size and height, right? People that have bigger shoe sizes tend to have bigger heights, right, on average? Okay. Now, the equation you use to describe that relationship that you're looking at is called the regression equation. So this is an equation that describes specifically the average relationship between a response and explanatory variable. Hello.
I just got added to your class.
Oh goodness, okay. Since you just got added to my class, I don't have an extra note sheet for you because I made exactly as many copies I needed. So just have a seat and just take notes on your own, and then this will be posted online, okay? Okay. All right. Oh, yay, thank you. Okay. So in a scatter plot, the response variable, which also some books call the dependent variable, it's plotted on the, what do you think, x or y axis? Dependent is the y, right? And the that should say explanatory. I kept wanting to go exploring. The explanatory variable is plotted on the x-axis. So the first thing you do is you collect your data. So you're collecting your data about like Fairbanks temperatures because you want to figure out like what happens here. And you plot your data over a few years and you ask yourself, okay, well, what is the average pattern? Is it a straight line? Or is it curved? Curved. And some curved data you can apply sort of fancy statistics to make it sort of uncurved, but you won't do that in this class. That's Stat 401, okay? But the point is you should always take your data, look at a picture, and kind of see what's going on that way. Pictures are really useful tools. You want to look at what is the direction of the pattern. So for example, if shoe size goes up, what tends to happen to somebody's height? Usually also goes up. If I increase the number of miles I run per week to a point, what happens to my racing times? They tend to go down. Or if I train, I usually get faster, right? Unless I burn myself out. So usually, yes? Okay. Another question to ask is how much do individual points vary from the average pattern, which means like how spread out are people? Like how good can you predict someone's height by knowing their shoe size, for example? Like, you know, how close are they? And another thing to ask yourself is, are there any points that are unusual? Like suppose, like, you know, most of your data that you plot looks like this, and you got one person like way the heck up there. Something strange going on with that guy, right? There's no, at least I don't think we're gonna learn any great way to tell outliers in this case. It's kind of an eyeballing it type situation. Does someone seem to be weird? So points that seem to be unusual, they might be outliers. And maybe there's a reason to get rid of them, maybe not, but just maybe. You could run your data analysis with them and then without them and like comment on the differences, for example. That would be like the honest way to do things. Okay, is that all right? Okay, now the whole idea of with the whole shoe size and height, if variable x goes up, variable y tends to go up, right? Which means if you looked at their picture, it's going to be a line with a positive slope. Does that make sense? So that's what's called a positive association. Two variables have a positive association when the values of one variable tend to increase as the values of the other variable increase. So both of them increase. They have a negative association if as one goes up, the other goes down. Right, so like as my training miles go up, my race times go down. And two variables have a linear relationship if when you plot them, they look like a straight line. So other things could be a sinusoidal, which would be like the whole temperature thing, daylight, stuff like that. Or there could be things that increase exponentially, not a line either. Okay. So this guy, positive association, negative association, or no association. So in this one, we've got height on the x-axis and hand span on the y-axis. Positive association, yep. As height increases, hand span tends to increase. And notice that, you know, most people kind of like follow, you can kind of think like, okay, there's kind of a line that goes through the most points possible in some sense, right? And the average pattern is, you know, sort of spread out-ish, right? There's some variability there. How about this guy? This is a plot of somebody's age and the distance at which they could first see a sign. Does that make sense? Like, so if a young person probably can read a sign before an old person whose sight is kind of going. Does that make sense? So as age increases, the maximum distance they could accurately read the sign went down. That's a negative association. This isn't on here, but it would be still good to know. No association looks something like ish, okay? There's this kind of like a big bubble of stuff. and there's no obvious up or down. It would be like a line with slope 0. Yeah.
So even though the numbers are correlated for distance and age, they're not, it's a negative association because that's just the way you word it from that.
It's because the correlation as a number can be either positive or negative, and we'll talk about that. I think it's on the next page, or is it? It might even be the next. I might be ahead. It might be the next lesson, but yeah. So the correlation as a number, we'll get to that next time, talks about direction and how strong. And so the positive part is a positive correlation, the negative part would be a negative correlation. But then the positive negative refers to, is it both increase together, or as one increases, the other decreases? Okay, so think. For these, do you think there is going to be a positive association, a negative association, or no association? So amount of alcohol consumed and performance on a test of coordination. That's going to be negative. As you consume alcohol, your coordination goes down, which is why you shouldn't drive. Yes? No drunk driving. Be good. Okay. How about height and GPA?
No.
There's going to be I don't think there will be any. None. We could sort of, yeah, look at that. I mean, if there was a correlation, it might have to do with differences between subgroups. It might be that girls did differently than boys, either better or worse. That would be and then the fact that you hadn't separated those groups might make it look like there's a correlation when there wasn't. Or athletes, yeah, because, I mean, so, you know, but I think that athletes wouldn't be a large enough proportion of your population to have a large impact. Does that make sense? You would need a pretty big group for that to happen, so having 2 semi-equal large classes might do it. But athletes is definitely possible. How about weight of car and average MPG? So as cars' weights go up, what happens to your miles per gallon? Tends to go down. That's a negative association. Okay. So a linear pattern is common, but it's not the only kind of relationship. Sometimes a curve describes the pattern of a scatter plot better, and if that's the case, the relationship is called nonlinear, or they made a fancy word called curvilinear. Curvilinear. Okay. So here's a figure. So on the y-axis is the average SAT score on math in 98 versus the percent of people that take a test. And this is for all 50 states. And I don't know if this is, I assume most of you are from Alaska, but probably not all of you, right? Yeah, so I'm from Minnesota, and in Minnesota, we don't take the SAT, we take the ACT. And I'm sure that's not the only state for which that is true. There are lots of other states that use the ACT. All the Midwest states, for example, use the ACT as kind of their litmus test, but you can also use the SAT. And the kind of funny thing that happens is if only 10% of people take the test, they tend to get really high scores. You see that? But once you get almost everybody taking the test, the scores tend to be a little bit lower. And so the thing, yeah, go ahead.
So you mean like if only 10% of us in this class took
No,
the
I
test?
mean like this is saying like if X is a state, each dot's a state, and in some states only 10% of all graduating seniors take the
Gotcha.
SAT.
Okay.
And this is the average scores that comes out of that. And some states 20, 30, 40, 50% take the SAT and then is the average score of that group. Yeah.
So would that be because when you have the higher percentage, because they're forced to, and so the amount of people doing it?
Yep, that's a completely legitimate thing. It could be that maybe everybody takes the test. And so just because it's everybody, it's going to bring the average down, right? It could be that in states like Minnesota where people take the test, they tend to be applying to schools that are not Midwestern, like probably fancy ones, like Harvard and MIT and other things that are kind of like, would require the SAT. So that probably is the reason you see this relationship. Does that make sense? Okay. So now that we kind of know what's going on, does that plot show a positive, negative, or no association?
Negative.
It seems to be pretty negative. Okay. And so explain. So I'm a big Doctor Who fan, so I always want to add an exclamation mark and say it in a Dalek voice. Explain, explain. If you don't watch Doctor Who, you really should, because it's hilarious. After you do your homework. Okay, so the explanation would be something like, as the percent taking the test increases, the average math SAT score does. The average math SAT score decreases. Okay. So explain whether you think the pattern is linear or curvilinear. Yeah, I would say that, so this is definitely an open-ended question where lots of answers are correct. I'd say it's pretty close to linear. Does that make sense? But it could be a little bit curved. Does that make sense? Because I think what you're saying is like it could be a bit more like this kind of thing is better than a straight line kind of thing. But the straight line isn't all that bad either. And there are criteria to use to judge, like, is this good enough or not good enough? And we're not going to learn those in this class. They're kind of fancy. So as long as you justify what you're saying with a reasonable explanation, you could say either one. Okay, so like what I said in my notes was that it was more or less linear. So more or less linear, perhaps slightly curved. Okay. All right, so about what was the highest average math SAT for the 50 states and the District of Columbia? And at that score, about what percent took the test in that state? So the highest point is this one. Yeah, it's like, 600 and something. So approximately, say 605, something. Okay, and then at that, here's where 10 comes in, right? So about 5% took the test of that state? Maybe even a little bit less, right? Maybe we'll say 4%. And I'm afraid I don't know SAT, but I think 600 is pretty high, isn't it? Yeah, okay. What is the max? Is it 8? 800? Yeah, okay. Okay, and who is the lowest?
475.
Yeah, that one's about 475, so approximately 475. And in the state, it's about 60% of the people in the state took that test. Notice it wasn't the point furthest to the right, was it? Okay, but that doesn't have to be. Just the general pattern is down, but doesn't mean it's always going to be down. Okay. Alrighty. We'll have spare time to do a quick quiz review before we start, so yay. So tell me whether a scatter plot would be an appropriate visual summary of the relationship between the following variables. In each case, explain why a little bit. So if you're going to use a scatter plot, the kicker is your variables must be quantitative. So it's okay if they're quantitative and discrete, meaning like only the values like 1, 2, 3, 4, 5, 6 are possible. That's okay. So are blood pressure and age both quantitative variables? Yes. So in that case, yes. Both are quantitative. Do you think there'd be a positive association, negative association, or none? Nursing, you're studying nursing. So as you get older, what happens to your blood pressure?
It goes higher.
So that's a
Positive.
perfect, yep. Not sorry to pick on you there, but positive association.
There would be a lot of outliers in there, though.
Oh, they're definitely, oh yeah, of course, there definitely would. Some people, yeah, they fix their health, yeah, but on average, it does do this. For the average person, it's not to say that it's your fate for the rest of your life, and it's going to go up for sure.
I don't know about that, because there's tons of kids, like, not kids.
There are tons of it, there are exceptions, but the average trend definitely is up. Yep. How about religion? I don't know why it says of country. Religion of country and opinion about strong gun control laws. So basically how religious your country is, and you can't do it because they're not,
They're categorical.
yeah, they're not categorical.
They're not quantitative.
They're not yeah, that's right, sorry, they're categorical, they're not quantitative. And what you could possibly do there is like make side-by-side pie charts or something like that, like, you know, let's compare Sweden's opinion on this to America's to, does that make sense? You could say, you have these 4 categories, and you could look and see how does the proportion of each change from country to country. Or you can make side-by-side bar graphs, you know, one for Sweden and one for the US. Sorry, I speak Swedish, so Sweden's gonna be my other country of choice. Okay, so something kind of cool is that this textbook comes with some data sets. And so there's a sort of like funnily type set little thing that says http://www.cengage.com, blah, blah, blah stuff. Yeah, on the notes? You see it? Yes, I mean, okay. So you can go to that thing and you can download data sets. And so there are some homework problems where you have to download the data sets so you can do things like make scatter plots with it. And the kind of cool thing is it's just going to put it into your Excel file. And then you can do things like order the data. It's kind of fun, yeah? You have to like order by hand. You can tell it to order the data for you, and thereby making less mistakes. So here's my general sort of instructions how to make this picture in Excel. If you have a different program and want my help, you got to come see me, or you could Google it too, because Google is pretty good at these things. So the first thing you do is you input your data, as in go to that website, click on the chapter that we're in, which is chapter 3, click download now. And you get this like zipped file, you gotta open it, and you can like pull out the one that you want. They'll have names that are matching the names of the stuff. And then, have you guys made scatter plots in Excel before? Okay, the thing you do next is you highlight both columns. So you highlight, and you have to have like the right button selected or the right part of it selected to see the sort of plots and graphs and stuff. So what I said next was select charts, and then choose scatter. If you can figure out how to make the labeling thing work, it'd be cool if you give it labels, or if you don't figure out how the labeling works, just write labels on your paper. Does that make sense? I inconsistently succeed at making my labeling thing work. It's just sometimes it's just a little bit fussy. So what this thing is telling you is, this particular picture is the average August temperature and the latitude of where that place is located. And we live at latitude 60 something, right? So what tends to happen to your average temperature as your latitude increases? It goes down. The further north you go, the colder you get, right? Or probably further south to a certain extent with Trust Point. Like, we're probably someplace, like, it's August, our average temperature probably is in the 40s, 50s? Probably 50s, 50s-ish, we average in the nights. Or is it average high? I don't know. So this is a negative association, right? Okay. So does it appear to be a linear pattern?
Yeah.
Pretty much, yep. So yep, it's a linear pattern. It's a negative association. Are there any cities that appear to be outliers because they don't fit the pattern?
The dot right next to the chart area.
Yeah, so maybe the dot next to chart area. That's kind of like me not making a very good picture. Chart area. That's Phoenix. And if you're in Excel, you can like click on that particular point and it'll tell you which one it is. But it's not obvious that it's an outlier, it's not hugely so. One thing that might make a city an outlier is its elevation, because both latitude and elevation is a temperature, right? So the answer is maybe, a little bit more wishy-washy than, But as long as you can justify it with some explanation, it's all good, yeah.
When you're doing this and you input the data and everything, do you want a regression line?
No, you don't have to do a regression line on it, but if it does it without you asking, it's okay.
Okay.
All right, let me just stop this.